What in the world is time travel? Well, again, we have to begin with our definition. Let's define this one more time. We defined it several times in several videos, but let's do it one more time. What the hell? There it is, idiot or idiot. You can pronounce it any way you want. Okay? Individual with big ideas. That's what an idiot is. And it comes from the Old Klingon, meaning big idea. We have little ideas, normal ideas, and then we have big ideas. Okay? And yeah, and so who are the people who have big ideas? Well, most of them are called special relativists. Okay? And they have these weird big ideas where they say that time can be bent. Time can be bent, can be warped, And they say that length can be stretched simply because a particle travels very fast. It stretches, it shrinks. Its length contraction, they shrink the ruler or whatever you're carrying, right? And the mass increases. It gets heavier and heavier and heavier. And what is mass? Mass is the quantity of matter. And so are we padding it with more matter? Is that what we're doing? That's why it's becoming fatter? Well, I don't know. How can it shrink, length contraction at the same time, become bigger, more mass? So, you figure it out. But that's why we call them idiots or idiots, right? Because they have big ideas. Okay, so we have to settle that because we're going to have a lot of big ideas right now, so be prepared. Okay, one of the things they talk about, one of the biggest ideas they have is time travel. They say that you can travel to the past or to the future. To the future is guaranteed. They already know that. It's proven. There's no discussion. To the past, there is still some debate. A lot of people say, well, I don't know if that's true. Others say, yeah, mathematics prove it. Maybe it's within the laws of probability. Science allows for it, physics allows for it, the equations allow for it. Okay, so they have all this stuff. So what are they talking about? Well, they're talking about this. They're saying, here you are in the modern world over there on the right, computers and so on. You walk through the time tunnel or rush through it at the speed of light or whatever, right? And you end up, I don't know, in the 16th century. You started out with a watch, maybe a wristwatch or a timer of some kind. And you end up with, a sand clock, an hourglass. Okay. So, yeah, this is the notion that they have. They call it science. You say, well, that's not science. That's not part of physics. It's philosophy of physics, philosophy of science, maybe, natural philosophy, someone said. No, here it is. Look, I'll prove it to you. Proof, evidence. Okay, here we have it. And here it is. This is, you just put time travel on Google. You just Google it. I got 7 million results for scientific papers. That's what I put in there. Okay. Now I didn't take the trouble to look at the 7 million. Believe me. I just took a first page there, a few of them, and you can see that it's quite a popular subject. Okay. In the archive there where people put their papers before they publish them, right? And you can see the dates there on some of them. And even to this day, people talk about this nonsense called time travel. So, yeah, what we're talking about here is that people actually write about this in the what they call the scientific literature. Okay? So, and the question is, who writes about this stuff? Does it involve philosophers of physics or natural philosophers or philosophers of science? No, it's mathematical physicists who write about this and try to publish their papers. It's theoretical physicists. It's what they call physicists who do all this kind of work. So here when you put them against the wall and you call their bluff, they say, well, that's philosophy of physics. Well, if it's philosophy of physics and that's not part of your job description, it's not part of your line of work, why in the world are you giving me a physical interpretation when you have no authority, no expertise to do so? Okay? So it's only when you call their bluff, when intelligent people confront them and say, you're talking nonsense, and they say, well, that's philosophy anyway. That's when they dismiss it. And who are the people who are writing all this nonsense? The so-called physicists, theoretical physicists, mathematical physicists. And so here we have a summary from SIAM, okay, Scientific American. Is time travel possible? Okay, and this came out in 2023, so you can see it's a very contemporary subject. Okay, scientists don't relegate time travel to the crackpot realm. Okay, they only relegate to the crackpot realm. You know, the rope model, maybe some others, right? That goes into the crackpot realm because they decide what's crackpot. But this is not crackpot. In fact, the laws of physics might allow chronological hopping. Laws of physics? What laws? Who dictates these laws? Is it the people in Cambridge or is it the pastors at Harvard? You know, science began to take time travel seriously in the 1980s. Time traveling to the near future is easy. If a person were to hang out near the edge of a black hole, only a few hours might pass for them, while 1,000 years went by for someone on Earth. If that person who was near the black hole returned to this planet, they would have effectively traveled to the future. That is a real effect. That is completely uncontroversial. It's a done deal. They proved it. You can't challenge it anymore. Going backward in time gets thorny. Scientists have come up with a few ways it might be possible. So they haven't, they still haven't let go of this. Okay, it's still there. Might be possible. A closed time-like curve describes the trajectory of a hypothetical observer that, while always traveling forward in time, whatever that means, how do you travel forward in time? Is it a tunnel? What are you doing there? From their own perspective, at some point find themselves at the same place and time where they started, creating a loop. Well, it depends on how many beers he drank. I mean, maybe he thinks at the same place where he started. I mean, how can he end up in the same place if he went forward in time or backward in time or whatever, right? And so this is possible in a region of space-time that, warped by gravity, loops into itself. Absolute poppycock, all this. Why does time travel depend on exotic matter? It is needed to hold open a wormhole, a tunnel in space-time predicted by general relativity, that connects one point in the cosmos to another. So you can see time travel is still alive and well, and we're going to make sure that it dies a sudden death today, okay? Let's make sure of that. And yeah, here you see Brian Greene. He's going into that time tunnel, okay? He's going into the past, and here it is. He comes up to where he was early in the morning, shakes hands with himself. He jumps into the time tunnel or wormhole, whatever that is. Doesn't look like zero-dimensional or one-dimensional. It looks like three-dimensional to me. And I don't know what it's doing there in the middle of the airport. But yeah, he does this, jumps in there, and he ends up with himself in the morning. Okay, and shakes hands with himself. Now, is this science or what? Okay. And we're going to debunk this nonsense today. And again, we're not going to debunk. Doesn't mean we're going to convince you. We're not interested in convincing you or persuading you or recruiting you. We're going to show the irrationality of what they're talking about. Okay, that's what we're going to show. Okay, so debunking here means we objectively show that it's irrational. What's irrational? Well, when you move a concept, when you have definitions that are inconsistent or you use them inconsistently, right? And the theory doesn't follow, the explanation doesn't follow from the assumptions. Okay, and here we have another fellow, and his name is Neil deGrasse Tyson. What does good old Tyson have to say about time travel? You're going to have to read here, okay? So here goes. I made it go as slow as possible so it allows you to read, so pay attention. Here goes. Okay, So the only reason they rejected time travel to the past, they accepted to the future, but the reason they have a problem with that in the past is that you can kill your grandfather, or your father and mother, or whatever, and then you won't be born. And so they say, well, that sounds like a little contradiction. Of course it's a contradiction, idiocy. So why are they even considering this nonsense in published papers by physicists? Okay, that's what that's got to be worrisome. Here you're paying all these people indirectly, sometimes through government taxes, etc. Go to these people, and you're paying for all that indirectly anyways. And these people are looking at time travel, and they call it science, or they publish it as scientific papers. And then when you call their bluff, they say, well, it's only philosophy. And it turns out no philosopher is writing papers on that. It's all so-called physicists, mathematical physicists, theoretical physicists. So that's what you got to look at. We have a contradiction there. Okay, and so how do we start this thing? Well, the criticism of this thing, okay, time travel. Well, we're going to present this. This is our universal movie. It's a tool that we use to challenge ridiculous theories from idiots, idiots or whatever. And what we're showing there is that in a single frame of the universal movie, it's a 3D movie. It's the one God runs, I guess. We have only this movie that's moving from one location to the next. Every atom in the universe is there in a single frame, and every atom in the universe only has distance with respect to each other, and it's moving to a different location. It's moving from location to location, but a different location means you're in a different frame of the movie. Okay, so that's the notion we have here. In a single frame, all you have is static concepts, okay, such as object, distance, location, and existence. These are examples, right? And there are others like standing, sitting. Those are also static concepts. They're not dynamic, okay? On the other hand, on the bottom there, you have, you require at least 2 frames for any of those. You need 2 frames to talk about motion, position, plasma, ether, field, energy, time, and so many others. Okay, so we're looking at a single frame. A single frame only has static concepts such as, especially location. That's the one we want to focus on today. Location. Okay, so hopefully we got that. What we're showing with this universal movie, we're only talking about objects. They have specifically atoms, right? And every atom in the universe is in that frame, and they all have a certain distance with respect to each other, and we call that location. Okay, the set of distances from all atoms to one atom in the universe, the gazillions of atoms to one atom, we call that location. The location of that atom with respect to all the other matter in the universe. That's location in physics. Okay, location is not, so much on the x-axis, so much on the y-axis. We don't care about that nonsense. Location is physical. It's just the separation from one atom to all the other atoms in the universe. Some very close by, and the other ones very far away. Okay, that's our starting point. I hope you understand what the purpose of that the universal movie is about. Okay, so here we have the Christian version of creation, right? And so we have a single frame there, which is Adam and Eve on the earth. Okay, so God creates the earth, I guess, in, he was moving over the waters, started creating piece by piece. And the question is, for any of those films, we want to know how he went from frame 1 to frame 2, where he suddenly creates man, from nothing, or creates the first bit of matter from nothing. So how did he go from the frame on the left to the frame in the middle? That's what we want to understand. What is the mechanism? What is the cause? How did he do this in his garage, right? We want to know the mechanism. And of course, there's no intermediate frame, because we're taking the next immediate frame in the universal movie. So there's no intermediate frame. That means there can't be a mechanism. We already have the contradiction in that image right there, because we go from nothing to something with no time. Okay, so that's the starting point for Christianity. Not very good. What God really does is really creates the universe eventually, I guess. And here you have a dynamic version of that. And you say, Bill, why did you put it in a single frame? Well, we put it in a single frame because that's how the mathematicians see this. They say that all that time involves motion, and it's dynamic. But they say the universe, the entire shebang, the entire universe, the entire space-time, which is what you're staring at there, is in a single frame. The past and the present coexist together with the future. It's all in a single frame. In fact, let's stop that so that you can see what I'm referring to. That's what they propose. Okay, they propose that that there's a single frame, and we have all the time in there. We have the past, present, and the future all in that block, which they call the block universe, space-time, whatever. And that's why they can get away with saying that if you're in the present, you can travel to the past because it coexists with the present. So you can go, each one of those slices there, by the way, that's time slices of every, what we call the single frame. But see, they put all those slices, which are different times, they put it all in a single frame of the movie because they talk about the block universe coexisting at the same time, past, present, and future. Okay, so let's get that straight, what they're proposing. Okay, so the only other thing that they do is they get rid of God. Poor old God, they get rid of him, and they have only, the block universe there, But the question we want to understand is the first two frame, not the frame gazillion there. We want the first frame and the second frame. They go back in time, what they say, and they say they go to frame number 2, and they start with a singularity. And so the question is, how did we go from nothing to the singularity? How did that singularity get there? Whatever that singularity is, we don't care. It's got to be an object because that object gave origin to all of matter. So we just want to know how we went from frame 1 to frame 2. That's what they need to explain. And of course, they say that frame 1 is unscientific, that it's irrational to ask that question because they cannot verify through an experiment or who knows what how that came to be. Yeah, of course not. That's the only thing that they have to explain. They have to explain how it was possible for the singularity to come into being. Okay? Until they can answer that, they have not understood absolutely anything, okay? Or they cannot explain anything. Okay, so what are they saying? And here's the key point, okay? Listen to this. Okay, here we have, under the universal movie, right? We have all the atoms in the universe. We're only going to look at 5 of them. And these 5 move with respect to all matter in the universe, okay? And so we only draw these 5 atoms, and you can see that they're moving across the screen, okay? And remember what we're going to do. We're going to go from 457. We're going to take one of those atoms, and we're going to take it to frame number 454, because that's what they say when they travel into the past. We can also do it in reverse. Take an atom from 454 and take it to 457. What's the problem with this? Well, let me show you what the problem is. The problem is that these people are not saying that anything moves in the universe. What they're saying is that every time that the atoms move to a new location, they in fact did not move to that new location. What they did was they created new atoms. They made copies of those atoms, okay? Because the only way you can move to find an atom in the past only if that atom is still there, okay? That means we're going to duplicate all these atoms, and here it is. This is what's happening according to them. They're creating copies of the atoms every time they move along, okay? So they're making new atoms, new matter in the universe as you move along time. There is no motion. There is only a creation of matter, okay? And here, let me show you a little picture, okay? Look at this carefully. I just want you to see what they're trying to do here, okay? Here goes. Okay? So this is what we see. We're saying that the guy on the left there can go visit the guy on the right only because we have all these frames still in existence. Otherwise, how can you go back and see the guy on the far right there? You can only see his hat there, cap. The only way you can see him if he still exists there. That's the only way you can shake hands with him. And that means all these frames exist simultaneously. That means we created new matter. This guy never moved. What he did was we created new matter. We created a new person for every one of these shots that depict him. Okay, so we're creating new matter according to the idiots of math. Okay, that's what they concluded. So there is no motion. Okay, what we have is creation of new matter every time you think you move. Okay, so let's start with this. We're going to show this. This is our universal movie. Okay, and just at random we pulled some frames out of there, right? And this is the universe, as you can see there. In each one of those frames, you have all the atoms in the universe. Okay, and okay, so what do we propose? Well, we propose that all that matter there is really a single thread, okay, that weaves all that matter, atoms and the ropes that interconnect them, okay? So this is what we're proposing. That's different from mathematical physics. Mathematical physics proposes discrete particles. That's what they've always done. We call it ether. That's what mathematical physics has always had. They just gave it different names, space-time, false vacuum. They're talking about the ether. They're talking about particles. Why? Because a particle is not a particle. A particle has become a number, a value. And what they do, they move these values, and they talk about the value that they move, and that's what they're going to put in an equation. They have no use for dots for particles. So the particle has stopped being a particle, a corpuscle, the classical one. And what we propose is that all atoms in the universe are physically interconnected, and there we try to show as best we can that the atoms are connected. Okay, so that's the difference with mathematical physics, the fundamental difference. Okay, and what comes out of this? Well, we have this. Give me a second here. We have this. The one on the right has become a single thread. We're saying that a single thread underlies all of matter, okay? And math phys remains the same. Nothing changed there, okay? And what does this thread do? Well, this thread weaves around and constructs what we call all the atoms and ropes that interconnect them. And here it is. This is how we visualize all this. We're saying that the thread turns into these two electric and magnetic thread that serve as connectors, physical connections between atoms. The atom is made of the same threads. Okay, that's why there's a single thread in the entire universe that weaves all atoms and ropes that interconnect them. Okay, and this is more or less what an atom looks like. According to us, that's a 2D version of it. Okay, and here we have our atom looks more or less like that, the 3D version on the right and the 2D version on the left. And what they're doing is quantum jumping by going back and forth. The electron shell or membrane, balloon, whatever you want to call it, expands and contracts at great velocity. What it does is, by doing so, it torques the rope, and that's why light travels always at the constant speed. It only exchanges frequency for wavelength and vice versa. Okay, and so there's your quantum jump. That's our atom. That's our model. Okay, so the point here is that we are proposing that there's a single thread in the entire universe that weaves all matter. So if we were to dismember every atom and every rope in the universe, we would end up with a single thread. And that's different than what mathematical physics has always proposed, and all dissidents, they all propose particles, discrete particles. They try to do it with discrete particles. Push, pull, the whole works. And that's why they cannot explain pull, because they've always done it with discrete particles, and you cannot pull with rocks. And that's why they never figure it out unless they change their assumptions. Okay, so this is the universe. Now we're going to untangle all matter. Okay, we're going to disassemble all the atoms in the universe, and we're going to have the thread there, okay? That's what you see there. But according to the rope model, matter cannot be at two places at the same time, like in mathematical physics. And so what happens? All these frames that you see there are really in existence. This is the only one that's there. Here, let me show it to you. And it's the one we're going to call the present, frame number 457. Okay, all the others are imaginary. In other words, they're in our brains. They don't exist in reality. Okay, so there's only a single frame, and that contains all the matter in the universe, right? It's like God froze the entire universe, right? Every bit of matter, nothing moves. There's only a frozen universe, static, and we're going to disassemble that, and there you see it. That's all you would see. So let's erase all these other frames. That's all we have, really. That's reality, the present, okay? And I like to put it this way, Father Universe, he only exists in the present. He doesn't live across time or through time or whatever they call it. He doesn't have motion, okay? Father Universe does not understand motion. Father Universe only has location, okay? I hope you're understanding, okay? It doesn't mean you believe in it, doesn't mean you accept it. I just want you to concede it now so that you can understand the theory founded upon it. That's the way we do science, okay? So we're going to concede the assumption just for the sake of argument, and here it is. We're going to have you, and there's you with a little atom that's on your shoulder. We're going to look at that little atom, the red one there, in frame number 457, okay? But remember, we're going to erase all the other frames, okay? Because they don't exist, okay? So all frames before 457 are in your head. They no longer exist. They happen. They're no longer there. In other words, all those locations of atoms, that disappeared. We have a new location, which is at frame 457 of every atom in the universe. And one of them is the one that you have on your shoulder. So this is the correct way of depicting that all the others do not exist. The only one that exists is the one frame that we just froze, and we'll call that the present. So far, so good, okay? And here, we're going to look at, we're going to try to move that atom to the past. Okay, that's what we're going to try to do. So here it is. But we're going to move it to a frame that doesn't exist. Okay, because that frame 154, really doesn't exist. But that's what these people claim that they can do, that they can take an atom, that's part of your body when you travel. So we're just going to look at one atom, and we're going to say, hey, we're going to make that atom travel through time, and it's going to go to a frame that no longer exists. Okay, because there's only so much matter in the universe. We're not creating matter every second as mathematical physics claims it does, because it says it can travel to an existing you in the past, or an existing Napoleon, an existing Caesar, or whatever. Okay, so that means Caesar didn't die. He's just in a different cross-section of time. You can still find him there, shake hands with him. That means he's still there. Okay? So this is important to understand, what we're talking about here. Okay, so here we have, we're going to assume now that that frame exists. Okay, let's assume it exists, because that's the assumption they make, that in reality, the frame when you were in the past, anytime in the past, still is there, and you can go see yourself. Okay, that's what they're saying. Okay, so we're going to assume that it exists. So that means we're going to look at that same atom in your shoulder a few days ago. For example, that atom is still there in both frames. It didn't disappear. We replace our atoms in our body every so often. You probably have a dinosaur atom now, or an atom that belonged to a dinosaur somewhere in your body. You ate something that used to belong to a dinosaur. That could have happened. But in a few days, we're going to say that that atom was still in your shoulder. Okay, and so we're going to try to take the one in your shoulder at 457 and we're going to take it to frame 154. Before we do, we got to show you this, because we're going to replace you really with every atom in the universe, meaning the thread that winds every atom in the universe. This is what we really have. And there's your atom. Okay, it's part of the thread of the universe. Okay, the single thread, as we call it, the closed loop thread that makes up all matter in the universe. Okay, I hope you follow through. And what are you trying to do? Well, this is what you're trying to do. You're trying to not only send it to an inexistent frame, but you're dragging the entire thread from our universe to that other frame where you have that other universe over there, which is the same universe as ours. So you're distorting completely our thread when you do something like that. You know, you're pulling on every atom in the universe when you go through time to a different frame, okay, to an inexistent frame, really. Okay, so this is what these people are saying that you can do. And of course, under the thread model, the rope model, you know, you can't do that. It's totally irrational what these people are proposing. And again, let's understand what we're saying here. We're saying that in order for you to visit yourself yesterday, that means that for every second, for every microsecond, gazillions of a second, every frame in the film, we made a new you. Every atom in your body, you know, instead of moving to that frame, what they did, they created a new you, and the original you was still there. And they created all these yous. You know, you have all these yous. That's the only way that you can explain what they're trying to do, which is to visit yourself and shake hands with yourself in the past. Or in the future, because this applies to the future as well. It's just as much nonsense to say you can go to the future as you can go to the past. And even they say, well, it's only for a little while, even for a little while. You can't go to, there's no such frame there for you to land on. There better not be, otherwise you've drank too much beer. You know, you got to take it easy with the beer. Okay, what are our conclusions? Well, here are the conclusions. Father Universe only exists in the present. He's always in the present. What is the present? Location, distance from atom to atom in the universe. There's separation between every atom in the universe. And the only thing that we want to add to this is that we say that there's a single thread that weaves all these atoms in the universe, but it still doesn't take away from the fact that Father Universe only exists in the present. Father Universe does not live, he's not alive, and he doesn't move through time, or he doesn't move at all. Father Universe always wakes up, looks at himself, says, okay, every atom is where it should be right now. They all have distance with respect to each other. Every atom has location. Each one is an object, all in a static, single frame of the universal movie. Then he goes back to sleep for an eternity again, right? And then he wakes up and again says, okay, every atom has location. I'm okay then. And so he always lives in the present, or exists in the present. As long as you keep the wording correctly, then you're going to make sense. But as long as you don't define your terms like they do in mathematics, you'll never understand anything.